Well, welcome to the Roof Hugger Retrofitting for Energy Savings webinar. This particular webinar is the sixth one of a series of 6 webinars that we conduct twice a year. We appreciate you attending, and if you have any questions, you can send them to sales@roofhugger.com, so on and so forth. Thank you for viewing the Roof Hugger Retrofitting for Energy Savings. This particular webinar is the 6th one of a series of 6 that we conduct twice a year, typically in the fall and the winter. My name is Mark James, and today I'm representing Roof Hugger, the manufacturers of retrofit metal over metal roof framing systems. This particular presentation is copyrighted. We do share it in PDF format by you sending an email to mjames@roofhugger.com. We'll send it off as soon as we get the request via email. You know, energy demand in the United States is usually not what everybody thinks it is. A lot of people think it's transportation. Well, it's not actually transportation. Transportation only represents about 29% of the total energy demand in the U.S. Our buildings actually consume 71% of all the electricity. Of that, commercial and industrial buildings are 50%. Of course, the balance of that would be residential at 21%. The problem with the U.S. building stock is commercial and industrial buildings actually waste energy. Older buildings suffer from poor thermal resistance and air and water infiltration. It is said that 24 to 30% of the cooling and heating energy is attributed to through roof heat gain and heat loss. That means 24 to 30% of the energy that we are paying for is actually lost right through the roof. That computes out to about $31.9 billion in wasted energy spent for the roof inefficiencies. Metal roofing in general, from an energy benefit standpoint, is number one, is the perfect platform for roof-mounted renewable energy equipment. It has a high solar reflectivity and emissivity, especially if it has an Energy Star certified cool roof system. Also, the EPA rates it as the most appropriate roof material for rainwater collection systems. Metal over metal retrofit actually improves worker, process, and manufacturing productivity. It presents the opportunity to upgrade to current federal and locally adopted energy codes standards, such as the Model Energy Code. It also allows for LEED registered projects to qualify for up to 29 points towards building certification. And it has the potential to take advantage of solar tax credits, grants, and funding. You know, it was once said that the cheapest, most reliable source of new energy is saved energy. That was said by Peter Turnbull, which is the principal really with the Pacific Gas and Electric Company. Retrofitting buildings for high energy performance lowers operating costs to improve the bottom line, and in many cases, it can do much more, even if the buildings are not the focus of the corporation, otherwise the building owner. Here you see a U.S. map, and this is the most current of the states that have adopted the Model Energy Code. The dark green states, of course, have adopted the most current Model Energy Code, which is ASHRAE 90.1 2013. Retrofit's energy saving considerations. First of all, let's understand the assembly of a metal over metal retrofit. You have an existing metal roof, and then you put a roof hugger subframing subpurlin system on top of that, and then you put a new metal roof on top of the roof hugger subpurlins. Well, that creates an airspace that's anywhere from about 1.5 inches, 7/8 inches tall to somewhere around 4.5 inches with our standard products. We can go more than 4.5 inches, but that's a custom product. We have done that on many, many occasions. But anyway, let's take that space between the top side of the existing metal roof and the bottom side of the new metal roof. You have this airspace. So what do you do with that airspace? Here's some considerations. You need to add ventilation to improve thermal efficiency. In fact, Roof Hugger actually recommends ventilating that airspace. It's very, very inexpensive to add ventilation. In this photograph here, you see an eave vent at the lower eave of the building, and that allows ambient temperature air to come into that airspace. And of course, it would be exhausted at the high point of the roof. You can add insulation to decrease the heat gain or loss through the roof assembly, as in this photograph. You can install a radiant barrier as well. And you can consider renewable solar energy technologies, as in this particular building at Goodfellow Air Force Base in San Angelo, Texas. This particular project was an all-inclusive roof assembly for energy research and energy savings research, I really should say. This particular project had an existing metal roof with an R19 insulation value, and through the process we added rigid board insulation, bringing that R value up to R51. In addition, it had solar thermal hot water heating in between the existing roof and the bottom side of the new roof, as well as we added thin film laminate photovoltaic solar electricity on top of the new metal roof. In addition, we added a rainwater harvesting system, which you'll see in the next slide, that we collected the rainwater and we dispersed it for landscape irrigation. However, rainwater collection can actually be dispersed for other purposes, as you'll see later. Insulated assemblies decreases energy consumption, no doubt. It reduces heat gain in the summer months and, of course, heat loss in the winter months. You can add rigid or fiberglass batt insulation without a vapor barrier. In this particular case, at this Air Force Base in Georgia, that is a rigid board insulation that's being installed between the roof hugger subpurlins and in the flutes of that existing 24-inch on center standing seam or trapezoidal standing seam roof. Of course, metal roof, new metal roof is put on top of that. But understand this, the huggers can be manufactured to accommodate any desired insulation thickness and R value. This particular insulated assembly, in fact, any insulated assembly, was eligible for an IRS investment tax incentive up through December 31st of 2016. But it could be actually reinstated by Congress at any one time. Of course, they're quite busy now dealing with other things, but that was a very, very huge tax incentive, as we'll explain later. Convective ventilation. This is something that we started with the Department of Energy's Building Envelope Technologies group at Oak Ridge National Laboratories. 16 years ago, we started researching above sheathing ventilation, otherwise known as ASV. Now, with ASV, during hot weather, the heat is actually dissipated out. During cold weather, the airspace between the old roof and the new roof actually is an insulating value as well. And you can actually achieve up to about a 30% reduction of heat gain through the roof. And then 45% when that new metal roof has a cool rating on it. You can get a greater reduction with a radiant barrier. It is vital to condensation control in that airspace between the old roof and the bottom side of the new roof. It can be incorporated with insulating cavities, as you'll see in a couple of illustrations coming up. Now, ASV, here's an illustrated roof, and let's go through it. There's your existing metal roof. There's your new roof hugger subpurlin systems. There's the new metal roof. And there's the ambient air coming up through a ventilated low eave system. And as that air goes into the airspace, it heats up, becomes buoyant, and moves upward by convection. And then the hot air is dispersed out or discharged out, exhausted. Of course, radiant heat is reduced 30 to 45%, and then heat loss in the winter just as well. Now, in this illustration, we'll show you an ASV application that actually has an R26 added insulation to meet the Model Energy Code minimum assembly for metal buildings. This particular one takes into account that this is an uninsulated existing roof. There's the existing new metal roof, the roof hugger subpurlins. You add an R16 minimum rigid or fiberglass insulation. You add an R10 reflective radiant barrier insulation on top of that. And then on top of all that insulation in the subpurlins and subframing system, you add a 1-inch high density vent block. That allows air to actually flow above the insulation beneath the new metal roof. And as air flows up in the existing roof, or the new roof actually heats up, then that air is dispersed out. Now, you can also integrate renewable energies, various different types of concealed or surface mounted renewable energy systems. Solar hot air recovery and hot water, as you can see in this photograph. We'll explain solar hot water in detail here in a few minutes. Or you can put a glazed crystalline photovoltaic panels. Now, one note, and I'll say this again, that glazed crystalline photovoltaic panels actually shades the new metal roof, and anything that would be within that space between the old roof and the new roof, it would be actually reduced. It's shaded so it's not as hot. You wouldn't get the benefit. Then you can put building integrated photovoltaic laminated solar electric strips on the new metal roof, as in this Goodfellow Air Force project, and that actually increases the efficiency of the airspace and utilizing an airspace to integrate renewable energy, solar hot air recovery, as well as hot water. Only metal roof service life is 60 plus years, which is an unpainted stainless steel metal roof through the Metal Construction Association service life research. It exceeds the 25-year life expectancy of photovoltaics. So let's talk about existing buildings. If you would go in and add photovoltaics on top of an existing non-metal roof, very possibly that roof is not going to outlive the photovoltaic 25 years. In fact, a common membrane type roof has a service life of about 23 years. So actually the photovoltaics has a greater service life than that membrane type roof, as in this case. So if the roof has to be replaced, well, first of all, you got to remove the PV, you got to replace the roof, and then you got to reinstall the photovoltaics in the solar energy. And then conventional overlays cannot claim this advantage. So, because of metal roofing's superior service life, it actually provides a 24 to 43% savings over photovoltaics on any conventional roof. Conventional overlay roof replacements must include PV reinstallation costs for that proper life cycle. Just take an example is if you had to replace the existing roof, well, taking the PV cost, the cost of the PV off of the roof, then replacing the roof, and then adding the installation labor and expense of materials to reinstall the PV, then you have to consider all that in the total proper life cycle costing of that roof. So what we're saying is if you have an existing metal roof, you probably don't want to consider putting a conventional membrane or overlay over that existing metal roof. You would be better off putting a new metal roof on it and obtaining a 60+ year service life. There's no costly reinstallation for metal roofing, of course. And then the other good thing about photovoltaics and metal roofs is there's no holes and no leaks. Both thin film and crystalline installations are mounted on the new metal roof with S5 type clips. Solar hot air recovery, it's very similar to ASV, but it actually collects that hot air that's in that cavity and redistributes it to the existing HVAC system. There is some remedial work that has to be done there to actually route the hot air into that existing HVAC system. Actually, the hot air in that cavity is approximately 50% hotter than the ambient temperature outside. So let's take an example. If it's 60 degrees outside, that air temperature in that cavity would be somewhere around 110 degrees. It was eligible for federal solar energy tax credits on the materials and labor. It can be incorporated into wall systems. And here's an illustration to show that. Like I said, very, very similar to ASV. However, same thing, existing roof, new metal roof. The air heats up when it gets into the cavity, becomes buoyant, moves upwards. And then the ambient temperature comes in, heats up, you damper the ridge in the winter, and you actually do not exhaust that hot air. You collect it and put it into the existing HVAC system with a solar powered fan. Actually, solar hot air recovery can actually be done on walls as well. Here's a project in Bethesda, Maryland for the USDA where they actually did solar hot air recovery on the roof and the walls. Case studies have reported that the energy savings from solar hot air recovery can actually be about $1 per square foot per year. Research is underway still at the Department of Defense for what they call an interbranch transfer. That's saying that once they have identified all of the true benefits of solar hot air recovery, they will transfer that to all the other branches of the U.S. government. It can be installed on the roof and walls, as I said, and it can be combined with adding insulation and other solar energy systems for a fully integrated roof assembly. So I said walls. Well, why not? And I have this, actually, I put this slide in all of the webinars just to illustrate that roof hugger subpurlins can be used as a subgirt over an existing metal wall. The picture on the right, that's actually an old World War II vintage corrugated tin building. And that particular building was for the Department of Energy at their Oak Ridge National Laboratories in Tennessee, where we added an R40 insulation to a non-insulated building and increased the wall thermal resistance to R40 using rigid board insulation. And then we actually did a 12-inch wide, 1-inch deep flush panel, metal panel wall, and we collected that hot air in there and actually brought it into the building. Solar thermal hot water, let's talk about that. It's a very, very simple process, very successful, and installed on countless buildings throughout the U.S. What solar thermal hot water is a glycol fluid that's in a flexible tube that is installed directly beneath the new metal roof. On the left side of this photograph, you can see a metal roof going down, and these are flexible tubes in a saddle, a metal type saddle that holds them in place, and that tube is basically 1/8 of an inch below the bottom side of that new metal roof. You can see it's very versatile, very flexible from the standpoint of getting in and around roof penetrations. Now, of course, on a metal roof with a subpurlin, those tubes would be routed the opposite, as in this residence here on a wood frame, building. On a metal frame building, where you have the subpurlins here, those tubes would actually run eave to ridge. You use this space, the actual space between that old roof and the bottom side of the new roof. Use the solar thermal hot water for space and or process preheat. You can actually use it for radiant heat in a building, as well as preheating an existing boiler unit, as in that Goodfellow Air Force project did. It has a significant savings of about a 3 to 5 year return on investment. And then thin film PV, actually, as I said, it'll increase the efficiency because it creates a hotter cavity between the old roof and the bottom side of the new roof. And it can be combined with added insulation, as you can see in this particular roof picture. Now, here it is illustrated just like we had before. There's the new metal roof. There's a dampered ridge vent. There's a vented eave. You can put optional insulation in it, or an optional reflective radiant barrier. You can put that circulated fluid in a flexible tubing, and it gets heated up as the air goes through that. Solar tax incentives, like I said, this is grayed out here because federal solar tax credits have expired, and which included a 30% of the entire labor and material in place cost. But that could change at any one point in time when Congress comes back and reinstates those tax incentives. However, there are huge state, local tax, and utility incentives, utility company incentives out there in the marketplace from one state to the next. I know personally that Georgia is a huge, supporter of any type of solar tax credits and incentives. If you want to explore your particular area, you can go to this website, dsireusa.org, and you can look in there and see what is available. Energy savings in addition to tax credits, local grants, and utility company programs are huge. Now, rainwater collection, real quick, it's ideal for non-potable use. It can be used in, as I said, landscape and grounds irrigation. It can be used for potable purification if it's purified and ran through a purification system. It's available with a subsurface storage tank, or as I showed you before, on an in-ground or above ground storage tank. One thing I do want to mention is this particular rainwater harvesting is not necessarily permissible by all states and by law. You might want to check with that. So that concludes the webinar. We appreciate you attending. And if you need anything else, go to www.roofhugger.com, or you can drop an email to sales@roofhugger.com. Thank you and have a great day.